So, hello everyone, and welcome to this weekly session that we conduct, Ask AuxEn Anything. And as you all know, that this is an online platform for civil structural engineers to interact with us and ask their queries or doubts that they may have related to any steel or RCC design concept or any project that they are doing or construction site issues that they are facing. So, this is the 60th such episode that we are conducting. And let us begin by taking this week's queries. So we will start from the Google form first, and then we will take the queries from live audience. Okay. I hope my voice is audible. And let me just take the first query. So first query has been asked by Sanchit Rana. He is a working professional from Chandigarh, and he is asking this question that I'm going to paste over here right now. So he's saying I'm doing a project in which I have designed a common NTA. I think non-tower area is what he means by NTA. I have modeled two separate buildings first in ETABS. Now I have to combine them. So my question is that how I can combine two separate buildings in common NTA and how we design NTA as per 16700 backstay effect, and which models I'll prefer for design building elements, combined one or separate one. Two buildings have separate height, so on which basis I have to calculate static fundamental time period, or if I have to export reactions of two models and apply it on the NTA, how can I do this in ETABS? Kindly explain the procedure for design and analysis for such type of projects. So see, what he is saying is that he has a structure like this. In elevation, maybe it looks something like this, and there is a tower 1, and let's say this is tower 2. In elevation I'm showing you, and this is his uh, non-tower area, and then this is the tower 1 and tower 2. So see, my suggestion would be to do to model it in a common model like this. Now it depends, first of all, that whether you are going to keep the tower area and non-tower area separated over here, because in some cases some designers and some consultants and owners like to separate this out. Okay, so if you want to separate this out, that means there is a gap between the tower and the non-tower area. If that is what you are going to do, then you prepare three separate models. Okay, one will be your for tower 1, one will be your for tower T2, and one will be for the non-tower area. And in that case, you just model it right till the bottom like this. All right, so this becomes your model 1, this becomes your model 2, and the non-tower area becomes the model 3. This you do if you are going to keep the uh, tower and the non-tower area at the podium levels separate from each other. So that is one of the design philosophies that engineers like to do, and this is what you can do as well. Now, if you are not going to do like this, and if you have decided to keep it joined together, so if it is joined together, then you should model it as a single model. You model it as a single model like this. Okay, so it will be one combined model that you will have to prepare. Okay, then your question is how to calculate the static fundamental time period. So that is slightly tricky, because what will happen that in ETABS it will be difficult for you to calculate the time periods. In fact, what you can do is that if you prepare the entire model and you give these diaphragm assignments to each level, give separate diaphragm assignments to each level. For example, if you're giving D1, D1 over here, maybe give D2, D2, and so on, and see the behavior that you're getting, the model time period, the model behavior that you're getting. It's possible that ETABS on its own will give you separate time periods for this portion and separate time period for this portion. But then the loads, again, the problem will be that whether or not it is applying the loads correctly or not. So maybe what you can do is, in such cases, you prepare one separate model and take 2 or 3 bays of the tower portion, sorry, of the non-tower portion with the tower. That means you model something like this, where you have the tower and some portion of the non-tower area, 2 3 grids, because that is the number of grids till which the non-tower area will have some effect on the tower behavior. So you model this in a separate ETABS model. In a second model, you model the tower to T2 area with some portion of the non-tower area modeled with it. Again, this can be 2 to 3 grids. Then for each of the model, you find out the model behavior, and from model behavior you find out the forces on each story level, EQ forces on each story level. ETABS gives you those EQ forces on each story level. So that you do for model 1 and model 2 separately. You note down those EQ forces. So maybe this is F1, F2, F3, F4, F5. This ETABS will give you, and maybe this is X1, X2, whatever it is. For each of the earthquake directions, you can do this work. Then you come back to your main model, and in the main model, you assign the diaphragms and put the lateral loads as diaphragm loads. So this load that you have generated from the individual model, you now apply it in your main model on the diaphragm levels. Okay, and then do the analysis, design, etc. Clear? So these can be some of the ways in which you can deal with this type of a situation. All right, and then for backstay, you can go through the requirements of IS 16700, where it tells you that how you need to do the backstay and how you need to take into account the backstay effect. So for that, you can refer to the 16700, and you will have to do a sensitivity based analysis by varying the stiffnesses. So that thing you can do as per requirements of 16700. All right. Okay. So this was Engineer Sanchit with his query. Then the next question is from Engineer Akash Babar. He is a working professional from Sangli. He has sent an email with queries attached. So I'll just quickly open the email over here. So his queries are he has shared PDF images. Please explain. This is Engineer Akash Bawar with his queries. Please explain analysis of slab. Which slab? I think he says this. I think he means this slab which he has pasted. Please explain two-way shear check at point loads. So see, for analysis of slab, my recommendation to you would be that you will not be able to apply moment coefficient method for such cases, because you have got point loads, you have got a concentrated area load over here. So your moment coefficient methods won't work because they are moment coefficient method won't work because it is strictly for uh, the conditions where you have full area load on the slab. So this method will not be suitable for you. Now in such cases, what you need to do is, because the moment coefficient method is not going to work, it is better that you model the beams. All beams need to be modeled. I mean beams, I'm supposing there are beams. So you model this situation in your software maybe do it on etabs or maybe do it on safe, and then try to run the analysis. And in a FEM based software, then it will take care of all these situations. So you apply this type of a strip load, you apply the point loads, and then find the results. Okay, so I wouldn't suggest you to go for any manual analysis over here, because manual methods won't help you in such situations. So go for uh, a FEM software analysis where you model this as a shell element and analyze. Please explain two-way shear check at point loads. So two-way shear check remains the same as we do for all two-way shear checks. It is just that first of all you need the, for this point load you will need the load size, that you need to know. Okay, so once you need have the load size, then you can check at d by 2 distance away. Okay, so let's say this is the load size of the load point, this is the point load, check at d by 2 distance away, and at dy 2 distance you find out the perimeter, and perimeter into depth will be the portion which is resisting the punching, and this is your punching load. All right, this is your punching load, and then you do the punching check in the normal manner in which you do your punching checks. So for punching calculations, in such a case, you will need the load point dimensions. So how will you get that load point dimensions from your, if this is a mechanical drawing, you can find out that this 40 kilonewton load that is acting, it is acting on how much area, or what are the plate dimensions on which it is acting, and then you can do the punching check. In software also you can do the punching check by just assigning, oh sorry, by just defining this point load size. So in software you have the option of defining the point load size. For that you go to punching check overrides. So if you are using etabs or safe, you go to punching check overrides and you assign the size of this load point, and then the software will do the punching check for you. Okay, all right, so this was his query. Then he has another query. He is saying, can we use bending moment coefficients given in table 26 of IS 456 for estimating positive and negative moment in slab for given uniform loading? So he has a circular tank. It has a perimeter ring beam. There is a central column. Then there are beams over here, and it's a uniform load. So he's asking, can I use the moment coefficient table? Approximately, if you want to find out the outputs, maybe you can, because it is supported on all sides. So maybe you may take some equivalent, assume it to be an equivalent square maybe, and take these as the dimensions of ly lx and then do it. Maybe this can be done in absence of any software. Maybe you can do it like this, but then remember, it will not be the most appropriate analysis, and it won't be the most appropriate, most accurate results that you would get. But it's okay if you are not able to prepare a 3D model. Maybe if you're able to prepare a 3D model, nothing like it, you can just quickly prepare a 3D model it as a shell over here, shell elements, and then find it out, find the moments, shears, etc., and then finalize the thickness. Please explain reinforcement detailing in the slab to cater for radial and circumferential moment. But for this shape that you have, you won't get a lot of radial and circumferential movements. Okay, radial circumferential movements you get if you have a dome like shape, then you get radial and circumferential movements. In this case, it's a plain slab. It's a plane means it's a planar slab in two dimensions. So I don't expect that there will be a lot of radial or circumferential movements in this. Reinforcement detailing, in such cases, you can just go for your normal reinforcement detailing like this, bars like this in one direction, and then bars in the other direction also. Okay. So no need for, I don't anticipate any circumferential or radial moments in this. Please explain one way shear check at curved edges of slab. What explanation do you need? I mean, you just need to find out the shear. Again, you won't be able to accurately estimate the shear. So, because you are not sure about the yield lines that you will get in such a complex shape. So, first you need to estimate the shear value, which for which you don't have a really good way of doing it. If you have estimated the shear, then the shear thickness check remains the same. You find out the VU, it has to be less than VC. That check remains the same. Maybe over 1 meter curved length, you can do this check. The problem will be to estimate how much shear you will get on those curved edges. And again, I'll suggest that it is better in such situations to go for a quick 3D model and see what type of behavior you are getting. Okay, all right. So this was Engineer Akash with his queries. Then we move on to the next query, and next query has been asked by Mr. Cheran Pandian from Chennai. He is a working professional, and he is asking what is prying force and where can I use, and where can I use extended end plate connection or anything else. See, prying force basically means that if this is your connection in steel, and let's say you were trying to pull this apart, or you were trying to pull this type of a connection, and it was held together by these bolts, let's imagine. Now if your plate was thin or not thick enough, what may happen, that this plate may undergo bending like this. And when it undergoes bending like this, although the force is T, you are anticipating T by 2 over here in each bolt. But because of this prying action, there will be some increased tension forces that you might see in the bolts, and that will be what you had not accounted for. Okay, so you are expecting that if this is, let's say, T force, I would get T by 2 in each bolt. But because of the prying means the plate, because it's not stiff enough, it is undergoing bending like this. When it undergoes bending like this, it adds to some additional tensile forces in the bolts which were not accounted for, and that may lead to problems in your overall connection. So this is the basic meaning of prying. How do we deal with the prying? If I provide thick enough plate, if I provide thick enough plate, then you would get little to no prying in your bolts. And if this was my bolt situation, then because I had thick enough plate provided, now you would get T by 2 and nothing extra or any additional force you would get. So to resist prying, instead of designing for prying, what we do is that we provide stiff thickness, or we provide stiff enough plate thicknesses. We provide stiff enough plate thicknesses so that prying will not be a problem. This is the general strategy that we adopt. Okay, understood. So where do we get prying? One of the connections where we get prying, one of the connections where prying is a real possibility is your extended end plate connection, where this is your column and my beam is connected through an end plate. We have discussed this type of connection design in our courses, and in the sessions also we have discussed this prying issue. So, Mr. Charan, I'll suggest you to have a relook at the sessions again, because you have already joined those courses. So, what I will do is This is my, let's say, bolt arrangement in an extended end plate, and this is stiffener. Now there is some moment, this beam is subjected to some moment, let's say, so there will be tension force in this flange. So now what I will do, I will, so this is a classic case of prying, isn't it? This is a case of prying where if this plate is not stiff enough, end plate is not stiff enough, it will generate some additional prying forces. So this thickness of end plate is found out in such a way, is calculated in such a way that it will be stiff enough and prying won't be an issue. So this is how we deal with the prying effects. And again, as I'm saying that in most of the connections designs that we do, we won't separately check for prying. The strategy that we adopt is that I will provide stiff enough thickness so that prying will not be a problem for me. Understood? Okay. So this was engineer Charan with his query. Then next question is from engineer Prashant Pawar. He's from Akola, and he's a working professional, and he's asking, while designing steel structure we have to consider temperature loads, but it's not mentioned in IS 800. Yes, correct. For that you need to go to IS 875 part 5. In that they have given the temperature load calculations, they have given you the isothermal maps of India, and as per that you can find out the maximum and minimum temperatures at your locations. You can also find out, I mean, the ambient remains 27, so as per that you can find out the temperature loads and then apply it in your software. But the load combinations, if you refer to 875 part 5, they just say that dead load plus live load plus temperature load, or dead load plus wind load plus temperature load, or dead load plus EQ plus temperature load. So the load combination factor is not clearly mentioned. Anyway, the 875 part 5 1987 was based on the WSM based design. So anyway, there were not combinations that were there as such, but what it is telling you is that temperature load needs to be combined with all the load load cases. Okay, but what is the load combination factor that you need to take, that is not clear. Now if you read the ASC 7, that is the American code for loading, over there also they mention, when it comes to the load combination factor for temperature loads, uh, they ask the user to decide based on their judgment. So based on the site condition and based on their judgment and based on the structure and its location, you need to judge and take that particular load combination factor. So in the American code also it's not clearly given that what is the load combination factor you need to take. Now generally some people what they do is they will take the same combination factor as of dead load. So that means, let's say if I have a load combination factor of 1.5 dead plus 1.5 live, they will take 1.5 TL. Okay. Some people may take just this type of a load combination with no factor involved. So different designers have different approach, but you're right, it's not very clear right now in IS 800 or even in ASCE 7 that what is the combination factor you should take. I'll also suggest you to go to IRC 6 once. IRC 6 is the code for road bridges. So in IRC 6, there are load combinations given for leading and accompanying loads. In that, they have taken up the temperature loads. So just have a look at the load combination factor they have used over there also. Generally, while doing projects, I tend to take the load combination factor for temperature loads as one and just combine it with the other load combinations. Okay. Okay. Next query is from engineer Dhruv Jyoti Ghosh. He is from Siliguri and he is an independent consultant. He's asking, during construction in a high seismic and high altitude region like Sikkim, where both wind velocity and earthquake prevail, should we consider both loads or load combinations? Of course, not in a single load combination. I mean, that is the basic. You have to make different combinations. You will have dead plus live, then you will have dead plus live plus EQ, then you will have dead plus live plus wind. I'm not mentioning the load combination factors over here that you can take from your respective code. Then you will have dead plus EQ, dead plus wind, and so on. So you need not combine EQ and wind in same combination, but you have to make separate combinations combining EQ and separate combinations combining wind loads with dead and live. All right. Okay. Then he's asking, I have attached pictures of double story steel truss building to be constructed in North Sikkim as residential building. Large numbers of steel sections are to be provided to provide solid base to puff floor panels. Can you help lower the steel weight in the floor without compromising insulation to vibration on each floor panel of size 8 feet by 4 feet? What would be the ideal grid of steel below each of these panel floors of given size in this case? Is there any ideal panel floor size that we can customize for convenience of laying of steel? So for that you need to go to your supplier who is giving you the floor panel. Okay, you need to go to them who is supplying this floor panel, and you need to ask them that how this supporting has to be provided. So if this is 8 feet, this is 4 feet, ask them that if I provide members only on the periphery, is it sufficient enough, or I need to so for in that case what happens that it's a 4 feet by 8 feet span. Ask if this is sufficient or you need some internal support also. The first point of information you need to take from your supplier who is giving you these puff panels. Get this data from them. That way you will understand that how the supporting needs to be made. So that should be your starting point. This is his image that he has shared. So once you know the framing that you have to do, or the framing required to support the puff panel, then you move ahead and finalize your framings. All right. So I think this is the same thing that you have done. Maybe this is 8 feet by 4 feet panels that grid you have provided. And then in the case, I mean, if this is my column grid, main column grid, okay. So you may have your main beam grid like this. All right. And then, so this is my main grid. Then you create some secondary grids. Now that will depend on how the puff panel needs to be supported. So maybe if puff panel needs support at every 4 feet, you will have to provide these secondary beams at every 4 feet and then lay your puff panels like this maybe. Sorry, not like this. So I'm assuming that this dimension is 4 feet and puff panel is supported along the shorter span. Yeah, so you need to also know how the puff panel is going to be supported. Is it going to be supported along the shorter span, or is it supported on all four edges? That information also you need to know. Once you note these inputs, then you will be able to finalize the framing. Okay. All right. So this was Engineer Dhruv Jyoti with his questions. Next, we have Engineer Rajendra Kamre. He is a working professional from Sangli. He has provided his doubts in the attached sheet. So I'll just show you the sheet. His first query is, last week I had asked this question. The queries are as follows. In water retaining structure, criteria for minimum reinforcement, is it total steel? Last week also I had told you you need to read this clause carefully. It says the minimum reinforcement in walls, floors and roofs in each of the two directions within each surface zone. So if this is your wall thickness, first of all it decides what is the meaning of surface zone. In some cases surface zone, this is surface zone 1 and this is surface zone 2. Now in this surface zone, in each of the two directions, so it's quite clear that in each surface zone you need to provide minimum reinforcement in each of the two directions. Now the surface zone width has to be calculated. There is a figure given after this table. You have not taken that in the screenshot. So there is a figure given which tells you how to calculate the surface zone thickness, and on the basis of surface zone thickness from the reinforcement percentage, then you can find out the AST required and then you can provide it. Number one. Uh, Second question is it total steel? Yeah, so I just said it is not total steel in each of the two directions. Read this line over here, in each of the two directions. For thicker walls, the surface zones are taken as the zones on the edges only. So this is surface zone 1 and this is surface zone 2. So you calculate the reinforcement in this region and 0.24 or 0.36% and then provide it. So you just read the table carefully and read the figure that follows this table. Okay. Then the next query is how to decide the horizontal reinforcement position inside. So generally, how do we decide whether the vertical reinforcement is to be kept closer to the wall surface or the horizontal reinforcement is to be kept closer to the wall surface? The general principle is that whichever reinforcement needs the maximum effective depth, that reinforcement you try and keep closest to the outer surface. Simple. So as per your tank dimensions, you need to figure out whether your vertical movement is greater or horizontal movement is greater, and then you need to find out, or then you need to decide that which reinforcement needs to be kept outer or inner surface. Okay, so the basic principle remains the same as we have in slabs, that whichever has the largest moment, that reinforcement bar should get the greatest effective depth. Then query number 3 is, in water retaining structures, criteria for minimum reinforcement as per ACI 350 is not clear. Is it the same as IS 3370? I'm not sure at this point in time that what is the criteria given in 350, whether or not they have given any criteria. You may refer to ACI 224 also, because some additional criteria are given in ACI 224 also. So you may refer to that. But at this point, I'm not sure about the exact provisions given in ACI 350. Query number 4 is for RCC tank wall design. If wall thickness is under control for bending moment but fails in shear, such case can I provide shear reinforcement and is it suitable? See, if your bending moment is, if your wall cross section is failing in shear, I am almost sure that it is failing in crack width check also. 99%, or I would say 100% chances are that if your wall is failing in shear check, almost 100% chances are that it is failing in uh, crack width also. Okay, so if it is failing in crack width anyway, you will have to increase the thickness and you will have to maybe provide more reinforcement. Generally, that reinforcement that you will have to provide for crack width check or to satisfy the crack width will be more than what you require for your normal bending. And if you once you increase that thickness and if you provide sufficient reinforcement that is taking care of crack width, chances are that it will take care of the shear check also. Understood? It will take care of shear check also. But let us imagine that your cross section is safe in crack width, it is safe in bending, but still it is failing in shear. Then you can provide shear reinforcements, but it's not practical to provide shear reinforcement because it is tedious to provide such shear reinforcements in your slabs. So I would recommend that if it is still failing in shear, increase the thickness of your walls in such a way that your VU is less than VC. Okay, that would be my suggestion. All right. So this was Engineer Rajendra Kamble with his queries. Next we have Engineer Adityaraj Mehra. He has just written connection and there is no question that follows. So I'm not sure what he wants to ask. Query not clear, not complete. So unable to take it. Then next query is from Engineer Edul. He is from India and he's a postgraduate student. He's asking in ATABS, what is the recommended approach for modeling a non-prismatic beam, dividing it into multiple beams with different depths, or modeling the entire member using smallest depth section? No, you also have the option of tapered modeling in ETAP. So let's say this is your node 1, this is your node 2. You need not divide it even, and there is an option to give tapered section geometry in ETAPS. So you go to that, search for that option. There is an option where you can give tapered profile in ETAPS. If you are not unable to find it, then you may do this as you suggested, that you are making multiple nodes, and for each you are defining some variable cross section so that you get a tapered like configuration. But I will not suggest you to model the smallest depth and analyze it, because then you are losing out on the actual stiffness behavior of your system or model. So if you are sure that stiffness is not a problem, if you are sure that if stiffness is not a problem, then maybe you can just go ahead and maybe not model. Otherwise, it is better that you either do the tapered modeling option is available in ETABS, or you go for this adding multiple nodes and then assigning different section properties. Okay. Next query is from Engineer Anukul Kumar. He is a working professional from Delhi and he is asking uh, is this visible? Yeah. So he is asking, I am designing a roof truss for a building of 30 meter by 36 meter with a base spacing 10 meters in X direction and 9 meters in Y direction. Although it's not quite clear to me, this is maybe 30, this is 36. So base spacing is saying in X direction is 10 and this is 9. So what is not clear is that truss is in which direction. Anyway, I analyzed the truss with same loading conditions using both limit state method and working stress method. I found that WSM gives a more economical size with smaller member sizes. For LSM, I used factor load combinations, and for WSM, I used unfactored load combinations while keeping loads the same. So, where is the query? Oh, okay, I missed that line. Kindly confirm which method should be adopted. Can we proceed with WSM if it is more economical, or we should strictly follow LSM? This WSM that you followed, was it the section, what is the section? Section 11 of IS 800 2007? Was it the section 11 of IS 800 2007? If you are online, can you answer this? The WSM that you followed, you're saying you followed WSM method. Was it the section 11 of IS 800 2007, or was it the 1984 code? So my thoughts are that if you are following the section 11 of IS 800 2007, this is WSM, and you are comparing it with your normal IS 800 2007 LSM based code, I don't think you will get any difference, because the strength calculation procedure is the same whether you are using WSM or LSM. Just that then you have to, in WSM, then you have to take 0.6 of those stress levels or 0.66 of those calculated stress levels. So if you are using section 11 of IS 800 2007 WSM, comparing it with LSM, I don't think there should be any difference in the values. So even if you are still getting some difference, go back and check your design once. But if you are following for WSM the 1984 code and then comparing it with the LSM based 2007 code, anyway you are not allowed to use the old code now because it has been superseded by 2007. So you are not allowed to do that. Understood? So first check your WSM based method, which code you are following, and I don't think there should be any difference that you will get in WSM and LSMs. Okay. Assuming that you are following IS 800 2007 for WSM and LSM both, you will not get any difference. Okay, so these were the queries that were put for this week. We don't have any further queries. So I guess that's it for this session then. We had good queries this week with a lot of queries that we had received in advance. So yeah, that's it for this week then. We will see you next session where with more queries. And if you want to ask your queries, the link for Google form remains the same. Throughout the week you can keep putting your queries, and once every week when we meet, you can, or we will discuss your queries. Okay, so this is the link for the Google form, and if you want to connect with us on WhatsApp, you can just click on this link to directly connect with us on WhatsApp. So I'm just posting this link. Yeah, so use this link to directly connect with us on WhatsApp. So I think that's all for this week then. Have a good week ahead, and till then, have a good time. We will meet you next episode where we will take uh, the queries that you asked during the week. So thank you everyone for joining, and bye bye.